After I finished my PhD program, was looking around and saw a startup I wanted to join. I was the second person hired, and it was one other scientist and myself were joining a team of two business people, and we had kind of a split. We used to say it was her job to get everything to work the first time, and my job to get it to work the next 10,000 times after that, which was great because we both really liked those two separate things, and those are very different skill sets, and you need them. You need them both.
Weaving like DNA strands on a fascinating roller coaster of endless learning, experimentation, and discovery of technology, where the destination is not the end and the journey is the most fun. This is the Helical Brew. With your hosts, Mike, Sura, Jeff, and Elizabeth.
Welcome, Eli Fine, to the Helical Brew, and this is our second guest, and we're calling this, I'm calling it, our SLAS 2025 lead-up series, as we ramp up to the biggest event in our lab automation industry that I know of in the world. If somebody has another one, let me know, but I think it's pretty much the biggest there is, and they now have their European show as well. I'm looking forward to that coming up later this year, but thank you for joining us. And welcome to Helical Brew.
Yeah, glad to be here.
Fantastic. We generally like to start our discussions, kind of loose, relaxed discussion around, what brought you into this industry, a little backstory of maybe, from university or even before that, as we heard from Will. Having a connection to Richard Feynman, which that was quite a discovery to hear that. But hearing what brought you to this industry and the passions that you have in this space.
Sure. Yeah, so probably a little more traditional approach than than Will's. I was in doing my PhD in bioengineering, and we were doing a bunch of stuff with PCR, mini preps, E. coli cloning. And it got to the point where myself and another grad student, we were spending the half a morning both just sitting doing mini preps, like batches of 40 after batches of 40. And so I was, getting frustrated. This was, not ideal use of anyone's time. And, I saw that there are robots out there, and I have a background in software engineering as well. So I was able to convince my PI that if we actually got this robot, I could make it do all of these, pick and place operations, as well as the, mini preps, all the PCR cleanups, all these things we were spending all this time doing. And fortunately, he believed me, and we got a Biomech 3000. Was my very first robot, and so that was how I got into things. And it was able to do. Needed a lot more tweaking than the salesperson initially said. Everything was just going to work out of the box, but so I got some firsthand experience on that trope of the the industry as well. And then after I finished my PhD program, was looking around and saw a startup I wanted to join. I was the second person hired, and it was one other scientist and myself were joining a team of two business people, and we had kind of a split. We used to say it was her job to get everything to work the first time, and my job to get it to work the next 10,000 times after that, which was great because we both really liked those two separate things, and those are very different skill sets, and you need them. You need them both. So that was doing iPSC, stem cell culture differentiation, into cardiomyocytes, which was really cool because when it works, you get to see them start beating. You don't have to run a bunch of Western blots, do a bunch of RNA expression. That's later for quality testing, but you can tell right away if it's not working because they don't start beating. So yeah, that was how I kind of got into things, and there built some work cell that was doing lights out feeding of all these cultures, which was fun, being able to, less fun sometimes being on the receiving end of the calls at 3 a.m. from the automated notification system. But that was fun to be able to set that up and really see the impact that had on our throughput and freeing up the scientists to be able to do do other more interesting things.
Is it fair to say that with each of these projects, you found yourself getting a little deeper and deeper into the software element and bringing things together on those different platforms?
Yeah, as it started that the stem cell culture is very uh, it's not deterministic. You watch them for a little while, and it might take this long. It might so it's harder to do direct direct super predefined protocols. You have to have a lot of flexibility built in, and also we were trying to run 20 or so different experiments in parallel that were 6 weeks long each and kind of stack them up. So ended up needing to create some custom software in house to kind of manage that. And then start to link things with we were running started off with just let's use the startup. So whatever we had at hand, we're like, oh, Microsoft Access can be a database, right? So let's do that. And then started scaling to the point I was like, okay, we need to go beyond this. So started looking at the AWS cloud and connecting things from there. We realized that the driver for the Lyconic or the Hamilton driver for the Lyconic incubator that we were using to store all these did not really have all of the capabilities that we needed. So we needed to create a custom driver for that. And so I got the chance to apply some of my software engineering background to that, being able to set things up where we had, tests, code review, deployment, CI pipeline, continuous integration pipelines. And then that kind of is something that I took with me going forward, creating systems at larger places as, we got more familiar with the cloud. As you guys are probably familiar, trying to do kind of complex programming within the liquid handler software itself is not always the easiest. So one thing I had a chance to work on a project with Sura in the past, and we were trying to set up a way to run this DOE experiment on a liquid handler. And the issue was the scientists were sending in, huge, they wanted to have a huge parameter space to be able to explore in, but we also needed to make sure that it was within the boundaries of what we were confident that we had tested would actually work on the liquid handler. And so we actually set up something where the liquid handler software called out directly to something that we had running in the AWS cloud, which did all of the much more complicated computations. We had a bunch of unit tests we were able to run there, and then that actually sent down a file that the liquid handler software then could directly ingest to be able to run. So we were able to keep the program that was running within the liquid handler software fairly simplified, but we were able to make these modifications, add new features, and run it through the standard software development lifecycle. We create a pull request, run it in the test environment, confirm things pass, push, and deploy it out to production.
Awesome. Yeah, even from my perspective, so working with robots most of my career, software generally tends to stabilize and as like a robot driver or robot interface to an external piece of software, and then it doesn't really get touched much. But in life sciences with instrumentation, I've found that you're constantly having to revise, update, work with a protocol, if modify a protocol, adjust to make it suit your needs. And what often ends up being the case is you're doing versioning across multiple different environments all at the same time, which is really complicated to do. And I know open source is something to take us in a direction where we're not reinventing the wheel as we we used in our teaser. But I mean, to me, I see a lot of that in the industry, and that's what you just described is working around that, getting to work with a single environment where you can do your life cycle management.
Yeah,
I want to interject though, because I think Eli just simplistically mentioned a body of work that is very complicated, and he deployed it in a time where not everybody was doing this. No one was interacting with AWS Cloud. No one was understanding that you can present like simplistic like versions of software that then actually have the credibility behind them to make sure that it runs the same way every time and catches errors. So I don't want to negate that, and I'd love for you to go into that a little bit of how you even leverage this software experience that you had in a space that didn't really have a lot of parallels with what the software industry had as best practices, right? Beyond the you doing 10,000 to your coworkers doing one, right? You also set up this whole infrastructure. I think that's a fantastic foray into innovation that we hadn't seen before.
Sure. I mean, it's one of the principles in software engineering is to try and create defined interfaces between different parts of your overall application. And so it was really about trying to isolate and really minimize what we actually were requiring the liquid handler software itself to do, and figure out how can we get as much as possible of the business logic of what we need this robot to do, from the point of the users coming, giving it instructions, things like that. How can we get all of that out of this system that's more brittle and harder to work with, into something that is something that we can follow these more software industry standard practices around. So that was part of it. There was identifying that, and it's even for people who have not worked a lot with software, even starting to use simple things just like get version control for all the files that are on the robot. I remember one time, I think this was again, Sura and I worked together for 2 years, so we have some shared anecdotes. But there was that time where we saw that somebody had, while someone was doing what
We
was
shall
supposed
not
to
be
be a
named.
very isolated change to the system. uh, we were about to merge that work into the main code branch that then goes out and gets deployed everywhere. And we saw, wait a minute, for some reason this teach point had been modified in this one file, and everyone looked at it like, that doesn't make any sense. And the person was like, yeah, that shouldn't be in there. I don't know how that happened. And so even just using simple things like a versioning system that allows you to very easily see the differences in what you're about to change can help catch those problems. And certainly we've kind of specifically chose dynamic devices as a liquid handler, because everything in their ecosystem is a text readable file, which is
Hmm.
a different, not the approach, unfortunately, that everyone takes,
There-
because you can't see a difference in files that are something in a binary format that only the liquid handling software can make any sense of. So there's a couple vendors out there who put everything in a text readable format, and there's a couple that don't. And there's definite advantages of being able to look and see specifically what has changed, because as we all know, anytime you're changing the code that actually runs on a robot, there's no real good way to completely test it
yeah.
in simulation, especially not just in pure cloud simulation. Even if you could get the simulation of their software to run, that only tells you so much. So the ability to look and see, okay, this is the only piece of code that was changing. It's not even a liquid handling step, or it is, but we know it's the specific thing. We are changing the volume by this much, and we did test that specific part of the protocol. So that's something that can really be helpful in my past experience in increasing the velocity that you can respond to the scientist saying, "Hey, we just want this real quick change," and actually having the confidence that that you can actually deploy that without fully revalidating the whole process, and be able to get someone else to put a pair of eyes on it quickly.
It
And it
sounds like
accelerates innovation, right? To be able to have XMLs generated, because then you could build open source tools like Robolint, which we built in Resilience.
Yeah, certainly. I mean, either open source or closed source, it helps having having your hardware be able to be something that other software can interact with easily. Certainly makes it easier to build tooling on top of that, for sure.
yeah, it sounds like
Yeah.
you were laying on top of something that didn't exist, like a CFR Part 11 layer on top of this. Like at the liquid handler level, it's like, no, it's not in there, but we'll put it on top of this. And so if there are any changes, I'm going to let you know. Is that a fair statement?
Um, I guess, I mean, CFR Part 11, yeah, I never really framed it that way, but I mean that is a lot of. I mean, I'm I know a little bit about CFR Part 11, and I know a little bit about, the GXP processes, but I do know someone who was, very, his whole career in software engineering, and then he came and he started working when we were at Resilience, and he started looking at what were the actual requirements for doing things in a GXP manner, and he looked at it and he said, this is just like this is just defining like best software engineering practices. Like you document your changes, you can see what's changing, you're only changing the part that you mean to, you have an audit trail of who changed what, and you have a suite of tests that validates that your system still works as it's supposed to. So yeah, I never really thought of just using Git version control as a means of being of somewhat analogous to CFR Part 11, but it certainly has a lot of parallels for sure.
Oh, that's certainly a topic that's coming up more and more often with, CFR Part 11, which I think naturally drives a lot of discussion around version control in general, where in a pure research environment, you can just, yeah, document for your own purposes, but not so much for somebody else to be able to track it and trace back any issues that might have happened. That was something that I had to wrap my head around a little bit with using robots in diagnostic environments. Even as a robot supplier, you're still having to look at it from their perspective of, oh, this software needs to be realigned. And it turns out that process also made development of APIs and things like that, I think, more straightforward for future users. Some of the things we learned from that. But yeah, very, very, very interesting.
Yeah, and I think it like everyone thinks of these regulations as being an extra burden, but if you have tooling that just does it for you automatically, like Git, like so certainly it took some work to find what are the actual files that we need to put under version control because they were in like the software for the liquid handler installed them in like three totally different folders on the computer, and it took us a while to be like, wait a minute, why is this one acting different than this development one is acting different from this one over here? And then we finally was like, oh, there's this other file that is in a whole different folder. But once we had that set up, I mean, I really almost view it as a necessity to try. I mean, I know a lot of automation teams don't operate this way. A normal paradigm is you got one person working on this project, another person working on this project, another person working on this project, and they're working as very, very independent members. But coming from experience doing software development, trying to bring that agile mindset into how can we, especially working in startups, we don't have time to have three different people working on three different projects that all finish 6 months from now. We need to figure out how can we apply the whole team to effectively work on one single project to get that over the goal line as soon as possible. And so being able to use a tool like Git allowed one person to be working on one portion of it, another on a different part, and then we can merge those two modules together. And now all of a sudden we've got more of the process built in a faster amount of time.
Awesome. Do you find that the data management is something that, I mean, my observations of even large pharma companies, startups especially, but it's interesting to see more projects early on in the company's existence around managing the data, right? Not outsourcing that task, just with the data you're getting from the instruments as part of your experiments, bringing that together and at least trying to do that on site as opposed to sourcing that from, a known vendor that's obviously, capable of doing that, but at a certain cost, and also maybe not exactly the way folks want to deal with it. Do you see that as a continued trend out there?
I think that I mean, a lot of the companies I've been at have been very small, like 5 to 25 people. So we've definitely done a lot of stuff in-house, and also it's just very early on, and even the way you want to analyze the data is not fully clear. It's like you analyze it once, then the scientists be like, huh, wait, can we change that? Or that doesn't quite look right. And so it needs to be very, very iterative. And that's certainly accelerated by having that's something that's done in-house. But I think it is also very easy, and this was one of the challenges that we ran into at Resilience, which was a much larger company, a lot more disparate types of equipment. Is it can be pretty easy to underestimate just how much work it is to reconcile all the different data types that come off of all of the different instruments that you have. And so there, one approach was we had something in-house that would just get all the files off of the equipment and get it up into the cloud. But from there, it was more flexible on kind of a department by department basis, whether they decided to try and analyze it in-house or work with an external partner. But it is, yeah. I know you guys have talked in the past about the lack of standards in the industry, but it is very easy at the outset of a project to be like, oh, it's just what, like it's 6 different file formats and 4 different instruments. It can't be that. It's not going to be that hard to to just unify it all and get it into a point, but it can spiral pretty quickly. So I think there's definite advantages to especially as you grow to working with some sort of SaaS platform that has decided to take on the burden of maintaining all the conversion of the different file formats into something more standardized.
Do you know if that was an intentional decision on the part of, I believe you said, Dynamic Devices, making it full text readable, or something they did on purpose, or a happy accident?
I'm not sure if I don't know if we ever directly asked them that. I don't know. Do you
Okay.
know, Sura? You've worked with them for a while as well.
Yeah, I've had a lot of conversations about with Kelly about like how he started Dynamic Devices, and he comes from like TCAN and the way that he built it, to make sure that it was something that was unique. I think when it comes to the software, it's a lot of like the founders' ideas and Kelly kind of coming together and understanding like who the software engineer is going to move forward with. I like the idea of the XMLs. I want to say that they thought of it like first, but I can't for sure say because I never actually asked directly. We should get them on.
Yes,
Maybe
I
that's a future
Well,
episode. We'll bring
I
them
know
on.
they loved us every time we said, please don't put all this stuff in one folder. We need it specifically outlined here because we're just going to move things around for you.
yeah.
Yeah, it
Based
is.
on what I know from them, is that they do intend to be kind of like open architecture, to kind of give more power to the customer, and with that alleviate their support side and customization, that they can give that power to the customer. So they have kind of a similar approach to what we're doing with Genera, which we also have an open architecture in the software where you can do scripting and customization yourselves. And that's why we kind of align in that way. And we've talked quite a bit about that as well. And our programmers also like their code, the way that the API works. It seems to be very flexible and very friendly for us to integrate as well.
It definitely gives power to the customers because I mean, we were able to create all sorts of tools and write like present a paper at SLAS. It was just really powerful what we leveraged from that.
Yeah, that's exactly what they're aiming for. Yeah.
Yeah, we certainly know there's varying levels of you're welcome to come in and work with our machine in all these different ways, and on both ends of the spectrum. I know one device I worked with when I was over at Thermo. Well, I didn't really work with it, but I supported robotics. Coming in contact with the instrument was the Vanquish from Thermo Fisher, and it's the Vanquish, mass spec like nothing else. Let me tell you, but this device used a software called Chromeleon, and we would get inquiries from customers, or I would, and I'm like, oh, how hard can it be? Well, turns out there's a pretty high bar in terms of cost to be able to use that instrument and interact with that software remotely. So they've really locked that down, and then you see on the other end of the spectrum much more wide open connectivity to instruments out of the box without having to add things. So
Or
I definitely get that.
colony pickers that shall not be named that you can't you can't even access their API to do anything.
a colony picker that is forever standalone. Is that what you mean, sir?
Yeah, it is curious the vendors that will charge, they'll have an extra 20 grand to unlock the API, and I'm thinking like this is the biggest win-win. The more we integrate it, the more of your consumables we're going to be able to use. I mean, I'm no business major. I guess they have some reasoning behind it, but that just always
Yeah.
surprised me. That seemed like it was such a clear win-win from both sides if they already have the API built to to just have that available. But yeah.
Yeah, it's a business decision. It's like the drivers themselves. I mean, sometimes there's varying levels of driver capability. But I think, the automation, the drive and automation and the increased use of these instruments and automation has really opened the door. I've seen some vendors step up a lot and do enhance the driver capability quite a bit. But it's going to be a ride.
Yeah.
I'm sure it's going to be a continued ride as to what's going on there. But open source seems like the more the better, right? I don't from a user's perspective, could you see any negatives to that, Eli? I mean, open source is always better for the user in general, right?
Yeah, I mean, I think that the decision, so I mean, like there's having an open architecture, I think is different from open source
Yeah,
per se. But yeah, I mean, certainly like Dynamic Devices is not open source. We have no
sure.
idea what their actual code that generates the program is. But I think having an open architecture is
That's what I meant. Yeah, the
yeah,
architecture.
yeah.
Yeah, it just maybe open source, maybe interaction opportunity. Different drivers or connectivity to a device that is proprietary, of course, inside. But yeah, having that open architecture to be able to create something of your own without having to go through a channel. I guess those binary data sets or the binary files you mentioned. I mean, is there any interpreter for those from those software or from those vendors to be able to work with that and get text out of it, or is it?
I'm not
That's a
aware
whole
of
other ball
one.
game.
That's a
Yeah,
whole
I
okay.
don't.
So it's just
I mean, I
one.
know there's because I mean, I've dealt with data files that are have been compressed into binary format, and there sometimes the vendors will release some script to be like, here's how you can convert it back, but like we made it binary because it really helps with these giant multi-gigabyte files. But I've I have never seen something that can, for example, take a Hamilton.met file and convert it into something that is text readable and then compile that back into something that the star can read. I mean, I know their HSL files themselves are text readable, but that's just the C level extensions that they have, not the code that actually runs the robot.
So how big was Resilience when you were there? Actually, both of you were there at the
Yeah.
same time. So
It was just over 100 when I joined, and
okay.
just over 3,000 when we left. It was a different experience than the other startups
I
I've
think it's
worked at,
faster
for
than Google
sure.
went from.
Uh,
Wow.
Well, they
it
were
was, yeah.
marketed like when I interviewed, they were marketed as like X, the next big thing, and there was a lot of like capital and excitement and like branding. And I think one thing I've said on the show is that Resilience did it right in terms of, what Rich saw as the opportunity for automation, and he thought with automation in mind first and like hired Eli to set the right practices from the get-go. So I think on that end, it was a good experience for a startup to think of that first. The business side I won't speak to because it didn't end, that great. But I'll let Eli mention that.
Uh, not gonna go there.
But startups tend to be
Yeah,
like that, where
but
they get a lot of capital and they get excited, right? What is your experience? Because that was my first startup, with startups of this kind, since you've kind of had it more than myself to pull from.
I mean, that's been the yes. I mean, the first two startups I was at were more kind of. I mean, I don't know. Maybe just everything now is this crazy thing where you get, hundreds of millions of dollars as a Series A round or something. But the first few startups I worked at, we were, working for several years to get, a $4 or $5 million Series A, and it was, pretty measured capex and things like that. Uh, that's when you're in that type of environment, I'd say when you're picking automation equipment, flexibility is always going to be key because you things are always changing quickly in a startup. And I do remember once I joined, and in the first 2 weeks, they're like, "We brought you on. We have this process. We're sure we're going to get a ton of customers for this. It has to be able to meet this throughput, and you need to get it done in the next 3 months." I said, "Okay, if you're sure we have to do this, the only device I know that can meet that spec is the Mantis, but the Mantis is very specialized. It's very good at what it does,
Yeah.
and it's the only thing I'm aware of that's going to be able to let us do this. But if we don't end up doing this, we don't have a lot of stuff that that it can be used for otherwise." And I, I gave my advice to the CSO, and that was my summary. And he said, "No, buy it. We're going to do it. It's definitely happening." And it did get it up and running. The Mantis was capable of doing it. It's a really great instrument, but unfortunately, the customer demand did not pan out for that specific thing, and ended up pivoting, and did not use the Mantis after that. So that's definitely some the core advice I always keep in mind. That was also one of the reasons we went with a liquid handler like the Lynx as one of the first things at Resilience, because it is essentially the 730i. It is very flexible for a lot of different workflows, and it has that open architecture that you can use it for all sorts of different things. So that's always something I like to keep in mind. But yeah, I mean, these startups that are getting tens of multi tens of millions as a seed round, or hundreds of millions as coming out of stealth after 6 months. It's I don't. It's definitely been a trend the last couple of years, and I know there's definitely been some a lot of examples where it hasn't turned out well. Um, but yeah, it definitely gives you a chance to work with a lot of different things. I don't know if that's a trend that's gonna continue, or if the VCs are gonna pull back more. That it's always crazy being in the startups, but I like them. That's the place I've always worked at. But yeah, you get to wear a lot of different hats, meet a lot of different people, get to experience different ways of working. So it's definitely something that I've enjoyed.
Cool.
Probably you probably put yourself in a lot of out of my comfort zone spaces in startups. Like you said, lots of hats. Well, I don't really like this hat, but okay, I'll wear it today, and I'll see what I can do with this.
Yeah, I think we're building out a lab space, and someone's like, "Can you calculate what the electrical needs are going to be, and how many outlets we're going to need, and where?" I was like, "Okay, let me go back my electrical engineering. Let's see. I remember it's volts times amps gives you watts, and
You become a
yeah,
facilities manager quickly.
yeah." Learned a lot about liquid nitrogen vacuum tubing lines, and other gas stuff. But yeah,
It
learned
is
some
fun
different
though.
things along the
Everyone's
way.
excited
Yeah,
about it usually, right? And the founders are like walking around. So I think the energy is high.
yeah, yeah. It's definitely fun, for sure. And a lot of people. Whenever I do always tell when when I speak with students who are finishing grad school talking about it, I do always say, well, it is super fun, but most startups fail, and they can fail at inopportune times. My first startup. I was there from the very beginning. We were in office space, grew to a lab incubator, built out this lab space, and after 4.5 years, ran out of funding. The official last day, we were auctioning off the lab equipment. The last day the company was in business was the day after came home from the hospital with my first child. So
Wow.
it's like it's definitely a risk you take when you decide to work at a startup, but it's something. It's an environment that I enjoy.
Yeah, this industry, I mean, I think we're all biased because we all want to see it continue with investment into startups within this space, and I really don't see how it can progress any other way. I mean, if you look at the difficulty in solving the problems, even for large pharma companies that have significant resources within those organizations. You're seeing a lot of changes around how do we do the experiments smarter, use the equipment in a smarter fashion, because they know they don't have the lab space. They're not going to build out the lab space. They can't. They really can't afford the capital to do it long term to have this everlasting, growing, capability of, as I like to put it, throwing paint at the wall so you can find a masterpiece. And so you have to just get smarter about it. I know certainly in a conversation I had recently, believe it or not, with somebody that works at a large pharma company, happened to be sitting next to me on the airplane back to Denver, and we were talking about the use of artificial intelligence in that process. And so, hearing it from him directly was, I think, really exciting to see some of the applications they're doing in their own informatics groups to deal with data smarter, so their experiments can be smaller and faster at the end of the day. But I mean, yeah, there are plenty of problems to solve that they don't have the bandwidth for. So there we have startups to go do it.
Yeah, and a lot of these assays to try and, to have better predictivity of how these molecules are going to behave in humans are becoming increasingly complex. It's not just, an ELISA where you have to worry about antibody specificity. It's these 3D models or, these very complicated, ways that, different binders work with each other. And so, another approach is that these startups are becoming specialized little places where these pharma companies partner with them to not just run a whole bunch of super simple assays and send back the data, but be like, hey, you have this complex model. We don't have the expertise to bring it in-house and do it, because it would require an entire team of people just to understand the science and troubleshoot what's going on. So as as the industry struggles to figure out how do we combat, was it Irum's law, the ever increasing cost it takes to get a drug to market. I think the ways to be able to understand what I guess actually going on with these these compounds and these complex therapeutics requires complex biology to interrogate it. And so it's not necessarily always going to be a viable approach to try and have a company in-house all these complex assays.
Yeah, you're seeing more partnerships or more companies that are being founded on the idea of selling a database or like Recursion, for example, in Utah, right? You now have access to this database that they're creating, and use that alongside other resources. So yeah, that's kind of cool to see how it's not just about, starting from scratch or doing it all ourselves. It's creating companies that can be leveraged for future development purposes.
That brings a whole
Very
different
exciting.
pitch coming out. You're not long, if you're going for a CRO as your startup, it's like, hey, now you're pitching business to business, not business to consumer product. Like you said, Eli, we're trying to find this one drug to help treat so-and-so. It's, hey, let's talk to, in my area, Eli Lilly, or talk to GSK or whatever. That's what you're pitching to and saying, we can tackle this, or they find you. I don't know, but maybe the AI CS or CROs are going to be the next big thing. I don't know, but
Yeah, and I think it's like when I've worked with CROs, it's mostly been like, okay, there's this very strict protocol. We want you, it should be very easy for you to execute it. We just need, because you have the capacity, just run it and give us back the results. And there's really no way you can mess it up, which is like, there's a lot of assays that can be run like that. But I think some of these more complex things, it's less of a CRO model and more of a partnership, because like, when you first run it through this new system, there's going to be some things that have to be, troubleshoot. There's going to be things where, new insights may pop up only to somebody who's very experienced with dealing with that biology. So I think it's generally challenging to pitch to venture companies that you want to just be a CRO, because those inherently don't scale. I think what's more intriguing to the venture companies, if you can convince the VCs that you're valuable enough to these pharma companies to be treated more as a partner, get some, not just a fee for service, but get some sort of percentage of potential upside of the molecule, because the pharma company does view you as a partner in making this possible, and not just as a a fungible, like, well, there's a million different places we could outsource this Eliza to. We happen to choose you. Um,
Yeah, I think that that is a good thing when you're choosing your partner is the flexibility that you can get with the solution. It's a very good point that you bring because it allows you to integrate multiple devices from different vendors and you can choose that technology as it comes along and your needs are changing in the science. How much flexibility they give you and how friendly that can be for the team in the lab to be able to implement these new technologies. That is when, the partnership comes into play. And choosing the right partner for that, I think, is really key.
yeah, when you're bringing tools in-house to work with, it's definitely can make a huge difference for sure.
That was something interesting that came up during our talk with Will, was about, how Ginkgo is actually for some of their customers, the customer has a very lean automation team, super lean, right? And they've got the science focus, maybe one automation engineer for a relatively large installation, and they're doing all of the automation stuff remote, but they're getting a lot of input, and they've got constant support available when they want to make tweaks and adjustments to the experiments that they're running, which I thought was interesting. It's a little bit of a deviation from the CRO discussion, but I think along the same lines of, the idea of mentioning a CRO, I think what you were saying, Jeff, is, the ability to maybe leverage resources in a different way internally, so you're not buying all those resources, if you will, but different approaches to that because I think you can often, well, as we've seen, right? I think companies that it's been taken over by automation people all of a sudden. We're the scientists. We got all the automation people. Yeah, so they're kind of mismatched, right? You don't have enough science to run on and keep all these folks busy. So and that's one way to avoid that. I thought that was an interesting approach that they're taking with their cloud web-based software and cloud model.
Yeah, I think it's always a bit of a risk when you say you're going to support something because you're kind of making a gamble that you're going to be able to have a pretty high ratio of things that you can install versus number of people you require to support them. But yeah, I mean, I think it's certainly possible that with Zymergen's experience and the scale they were operating at and Ginkgo's, that they have collected enough data. Because one of the things is always trying to tell like when something's starting to drift out of spec and trying to catch that beforehand. But they very well may have built up a system because of their large scale experience that allows them to have enough automated monitoring that they can prophylactically prevent most of the most of the problems.
Yeah, yeah. Well, maybe switching gears a little bit, question came to mind. It's like, what right now is most exciting to you that's happening?
See. So, I mean, something that I had my eye on, but I haven't had a chance to interact with directly yet is this idea of, what if we just have these, humanoid robots in the lab, and instead of having to build all these devices and make them compatible with, a standard plate gripper and all of these other things, what if we just can have something that walks around and opens up the centrifuge the same way that that people open up the centrifuge. And really the issue I was talking with a friend about the other day, and I think one of the I mean the vision aspect is certainly going to be something to solve, and like how do you make sure it's moving precisely enough, but there are so many applications with robotics that are trying to solve that same issue that I think that will get solved before it becomes a bottleneck in the lab. But I think, at least from what I've looked into it so far, one of the things is, having sufficiently versatile end effector manipulators,
Mm-hmm.
because I mean, maybe you can get something that really works just as well as a human hand, but maybe you can't. Like, how can you swap out those effectors on the fly, because not everything can be done with just a two finger gripper. So that's been something I've had my eye on, and there's a couple academic labs that have some cool videos they've posted on the subject. But that seems like it might be one of those things that never fails to materialize, or it might be one of those things that completely changes what what laboratory automation means 10 years from now.
Yeah,
Yeah.
it's it's a in the robotics world, it's a far reach, mainly because of the vision element that you mentioned, or connecting the vision to the end effector. But I think it's, as you said, it's one that there's so many problems in robotics and automation in general, including self-driving, that are reliant upon the similar R&D, or I was about to say the same, but it's not quite similar, research and development progress in the machine vision space. But a lot of it is, well, being stubborn. I mean, Elon Musk was very famously said, or was very famous for saying early on in self-driving cars, was, we're just going to use cameras, no lidars. No, it doesn't. I used to work by the Googleplex in Mountain View, so I would see the early stage autonomous driving Waymo vehicles, which were wires all over the place and lidars straight out of the industrial automation factory. And slow now they look like just a little cap on top of the car with a few things on the corner of the car, and they've dialed that down. They perform 50 times better than those original ones. So I feel like, yeah, it's going to happen at some point, but it's just connecting the dots in some really tough machine vision problems. But I'd like to see that too myself.
Well, I'm curious your take on this, Eli. Do you think that we're at a point? I know there's always going to be skeptics of, okay, yeah, you showed me yet again another humanoid type robot or what have you, Boston Dynamics, whatever. Do you get a sense that people are at the point where they're like, I'm sick of the hype. You better start producing, especially guys on the VC side. They're like, I ain't giving you any more money. You produced it, but tell me, where's the application? I want my return. What do you feel about that?
Yeah, I mean, I haven't followed that space that closely. I mean, I think Boston Dynamics gets a lot from the Department of Defense. But in terms of yeah, I mean, I think the mobile robots in the lab, the ones that are just on wheels, with a gripper arm moving around, those have been out for a while, and I I'm not sure how much they're taking off. I don't know. Maybe you guys at Redisoft have integrated with a lot of them, or Mike, you've put you've put your precise arm on a lot of them. I'm not sure. Um,
We have a
but
whole other
yeah,
podcast about that.
yeah, but yeah, um, I'm not deep enough into that to really know. It just it's been something that seems like it has some exciting potential.
Yeah, there's one company that I follow, which isn't humanoid based, but it's called Slip Robotics, and it's all for freight in the trailer. And they basically have these very low carts, and all of the freight sits on these carts. I think they have 3 in there for a regular 53-foot trailer. And these carts will just come out, boom, 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 really fast, and then they can reload pretty quickly. So
Yeah, I've seen that video too. Yeah, it
the
looked neat.
freight industry is picking up on this, and they're like, we're moving really fast with getting our stuff in and out of the truck, especially when you have a comparison between a forklift driver. Nothing wrong with the forklift driver, but it's about time. I need to get these trucks flipped and back out. So I think that's pretty cool to see other industries, simplistic as it sounds, just a cart, but it's, drive it in and do it while you're gone again. It's nice to see those other industries as well taking interest in simplistic but effective robotics.
And that is the limiting factor. You mentioned, government funding. I mean, that's a big part of why Boston Dynamics has been able to progress the way they have, is when you have the unlimited budget of a government program. I mean, for a good chunk of my career, I lived next to Lawrence Livermore in California. The projects they can go after is just, it's, an unlimited budget effectively. I mean, it has limits, but I mean, they can continue looking at a problem for 10 years, 15 years, 20, 30 years as part of a program. And I think, yeah, you sort of see fits and starts with a lot of these technologies, and we're seeing it in self-driving. I mean, if it weren't for the fact that the cars were selling anyway, that budget would go away for developing further self-driving capability. And unfortunately, the humanoid robot doesn't really have a market without the self-driving capability. So we can't like separate the two like we can a car. But if that were the case, I'm sure the rate of development will be much faster. I know one area that the government had looked at with humanoid robots was a field medic, essentially, where you could have a medic system with a humanoid that could come out of a box, take the patient, put it on another mobile robot, and take them away. But that's one that they look at here and there every so many years, and so yeah, we'll see if we get more research. Same in the pharma industry, right? I mean, if something gets only a little bit of attention, it takes 30 years to solve. If it gets a lot of attention, it might take only 3.
But it might not be the full version, right? Like we've seen that in other technologies that come into
Sure.
the field, like, the Verispan tips that PerkinElmer had on their Janus systems, right? They had the patent on it, but Hamilton and other companies were able to co-develop based on that idea. So as things like grow in their development cycle, you still are able to put that brainchild in other folks, right? And then they can innovate and produce things on the market that are actually usable. So it might not be a whole humanoid, android or whatever you want to call it. What did you call it, Eli? Robots, right? But the different pieces can lead to other architecture that might actually benefit the space even more.
Didn't we sort of see something like that with the, was it the Baxter? It had like 2 arms, a robot, and a face.
Rethink robotics, yeah.
Yeah. I think they were headed in that direction. Sort of, again, you go with the manipulators, the phalanges, if you will. But so trying different things. Sometimes you just have to break out of the mold of what you see. It's not always going to be the hand type of thing. So.
Yeah, and something came of that, really. I mean, the robot didn't really go anywhere, but the software approach and the approach to programming robots and interacting with robots that Rethink did, I think, has carried, the torch has been carried on by other companies, as well as Rethink. I don't know if you know, but Rethink is back. They actually were purchased, and the brand is back. So you won't see a robot that looks like Baxter, but it won't.
ABB also has a dual-arm robot.
Mm-hmm.
The Yumi, right? Yeah. The Yumi robot, which was really driven by electronics market, being able to do that benchtop assembly, which is similar to the lab, and being able to have 2 arms to interactively assemble parts or unscrew things, etc. So yeah, we'll get there at some point. Anything else that's catching your eye, Eli, out there?
Something else is it's still pretty slow overall to take off, but I am seeing more kind of true things that are open source in the biotech pharma space, and things they're actually sometimes being driven by big companies. I was kind of heartened to see that over the last 6-7 months, Novo Nordisk actually open sourced like 6 or 7 drivers that they had developed internally for some instruments.
Wow.
And it's been happening for a bit longer in the data analysis space, which I was actually surprised because a lot of concerns that companies have, like, oh, well, if you open source this, it's our secret sauce. Someone's going to gain a competitive edge over us. And I would have thought that would have been more of an issue, but there's been collaborations that I'm not going to make any guesses as to why, but just looking at it, it seems like a lot more of the European companies are the ones that are kind of been
interesting,
most prominent in this space. Yeah, a lot of stuff from AstraZeneca, Novo Nordisk, Bayer, and it was interesting. Even some of the projects. There's a page that somebody wrote a bot that kind of pulls through GitHub and looks at all the biopharma companies things and kind of ranks them by how many people have started them and have been using them. And one of the ones that was near the top of the list was really just something to help configure something in the AWS cloud, which really kind of hit home. Just I think of how many hours have been wasted of, people just building these same generic things over and over again. You switch companies, you're like, they don't have this. I like kind of remember how it worked at this old place, but it's going to take me a while to build it back again. And most of the time it's not what we're doing in the robotics, the fact that we can control this instrument, or the what fact that we've figured out a way to automatically install this software on this computer, is not what's giving our company a competitive advantage. It's the science going on, and the fact that we have the people on the automation team know how to understand the science and pick the right solution to solve the problem. So it's slowly gaining traction, but I think that hope, especially as more and more people starting their career in biotech, have more of a foundation in software, at least to some extent, that hopefully that's gonna take off more, because I think that's something that really slows down the pace of innovation in biotech and biopharma compared to in the software industry, where like the it's the standard basically. Like Amazon, Facebook, all of these people have created these open source libraries, and they've earned back from it because other people in the community have contributed to it, found
Right.
bugs in it. Because I was like, if I would much rather have somebody else using my code find a bug than somebody at my own company. And some companies I've been at have been more open to it than others, and it doesn't cost anything. It's often cheaper to open source it because you don't even then have to pay for the hosting costs. And one kind of unexpected benefit I found was that it really makes troubleshooting it easier, because if the code's already out there, I can post on a forum, be like, hey, this thing isn't doing exactly what I thought it was, or I can show it to a friend, and that was really helpful. So it's yeah, hopefully it's something that takes off more, because sure, everything that you open source is not going to become a hugely popular thing where a bunch of people contribute back to it, but the the there's just seems to me to be very little downside. Not that you should open source everything. Some of it
Sure.
does give you a
No.
competitive advantage, but bits and pieces, and then over time the base level for what is actually driving a competitive advantage keeps rising, because so much of it is just out there, and it's not like everyone gives away everything all at once, but it's one of those things that compounds over time and can make it so that people can move into companies to move into a new uh, therapeutic area they're targeting. Like, oh, there's these data analysis packages on how to do it, there's these drivers on how to integrate with these instruments that are more commonly used in these field. Benchling is, I've just today, just ahead of this podcast, I looked and I saw that Benchling a while ago, 2 years ago or so, made this big to do about how they're partnering with Allotrope to tackle this problem of how do you convert all of the different data formats from all these different instruments into something more standardized. And I was actually pleased to see like the people who were adding contributions to it were not just people on the Benchling team. There are people from various different companies who have said like, yeah, I got this instrument and I was going to write this code anyway, so I'm contributing it here, and because we're using this library, and I wanted to also be able to parse this file that we use, and now that's out there for for everyone. So uh, yeah, I'm hopeful that we're at the beginning of that ramp, but that is definitely, especially with my software background, that's one of the big differences I see, is that the biopharma industry, the laboratories are, there's very little you switch from academia where everything's like standing on the shoulders of giants, everything has to be open, to
Yeah.
all of a sudden there's nothing, like even things that are clearly not anything that is giving the company any competitive advantage, or like, no, just this is not what we do here.
I
I
love
love
that,
all the
standing on the shoulders of giants. I think that's so important to make sure that like you're building that forward, playing that forward, right? Passing that knowledge along.
I'm
And
sensing a
and yeah, I mean, it can't be all altruistic. Like there has to be a, a business advantage, but I think there are, demonstrable reasons why the downside is extremely low. It's pretty easy for anyone to look at a section of, a project that someone's working on that's a piece of code and understand, is this actually material to our, business secret sauce or not? And I mean, the upside, again, it might take off, it might not, but it's also, it helps with recruitment. If people like to work, because I mean, even if it's not a direct, bottom line business need, when you're trying to hire people, you're looking for something to stand out, and people do like that feeling of, hey, I'm working at a place that does create open source tools, or at least can open source their stuff, whether or not it becomes a popular tool or not. Who, we'll see. But again, that ability to make it much easier to troubleshoot, because it's out there, and there's so many. There's been several times in the past where I've been me and my team were just banging our heads against this a company that was very open source forward in the biotech space, and we just posted let in the forum, be like, hey, here's this link to this section of our code. Why is it not doing this? And someone was like, you guys forgot
Amazing.
That's awesome.
Getting the community involved. That's
Yeah.
fantastic. Jeff, you were going to say something?
No, I was going to say, I sense a theme from the last episode and this episode, and you said it very early on, Mike, reinventing the wheel every single time. I love the fact that if we do move towards this collaborative thing, it's not our secret sauce to share this or to share that. Kind of reminds me of Node-RED software, which I saw a stat the other day. The guy who invented it worked at IBM, Nick O'Leary, and he said that they've put out, because it was community open, like 3,000 nodes that had been developed over the course of time to do certain functionality. Well, he had just retired from IBM, young guy, relatively speaking, and now he started another company. I think it's called Flow Fuse or something like that. Again, based on his co-invention with the company. Now because all those 3,000 nodes weren't necessarily all created in the standard that you would like. I think that would drive any software engineer nuts. It's like, the standard's right there, just please, just normally, so it can be useful. But now they're using it, and they're moving more into the manufacturing space. So simple connector nodes, flow programming, those types of things. So yeah, it'd be great to see that.
Oh, that's fantastic. I like all the different angles you put on it, right? So here's another research company that's using drivers, and using the instruments. And then here's another company that's making the instruments or making devices. I mean, there's all kinds of different models, or the service in the case of AWS, right? I mean, it's a lot easier to have a trailhead to using AWS than having to rock climb to use AWS, and being able to have that, here, just you still got some work to do to integrate it. However, here's a nice starting point for you to work with, so you don't feel like you're starting from scratch and spinning your wheels just doing something that somebody else already did, or and you just can't get to it. So a fantastic look into that, and I'd love to see more of it. I mean, in robotics, it's become a big thing, open sourcing robotics, because I think the problems, especially in vision. There's a lot of open source on machine vision, which is great because it's a really hard area to do, and you absolutely need as many eyes on it as you possibly can, especially some of the techniques for processing the image and doing that faster. Even though we've got incredible computing hardware now, you still need eyes on it to make more of it. So shall we do we're coming up on our about an hour.
I know. I feel like we can talk to Eli forever here.
I feel like we could too. And if you got time, we're happy to talk more.
But we promised him a pick of the week, right?
That's right. You read my mind, sir. What's coming up next? A pick of the week. And as our guest, you are in the number one spot.
All right. So I've been working remotely since even before COVID, and at one company, they gave out fitness trackers as to help us with like an internal competition. I mean, it came from the health insurance company,
Okay.
and I put it on. And after a couple of weeks, I realized I was only getting 1,000 steps or 2,000 steps a day, and I said like that's not good.
That's not a lot.
So I mean, I had a standing desk, and I looked around, and I found a walking treadmill that I can put under it, and you guys can. My one criteria there's a lot of different ones you can look for. My one criteria was that you can't hear it on the conference calls, and I know everyone always can see me
Yeah,
moving
I don't hear
around,
a
but
peep. It's yeah.
yeah,
This is how I'm used to looking
so
at
yeah,
Eli, constantly in motion during meetings.
yeah. Yeah, so it's great. I went from 2,000 steps to try and win the competition to like 27,000 steps the next day, which I did win the daily step count, but I was feeling it the next day. I'd not recommend that steep of a jump, but it is like just absentmindedly doing this. If I'll easily, like on a regular day now, I'll easily get 20,000, 25,000 steps. I think there's one competition between me and one other person. We really went at it one day, and I think we were like 37,000 steps or something.
Wow.
But just from walking, even if you're walking, 1.5 miles an hour for 8 hours, it
Makes a
can
difference.
add
Yeah.
up. So yeah, the one I have is Sunny Health and Fitness treadmill.
Okay.
Uh, got it. It's on Amazon. It's only like $120 or something like that. Would definitely recommend it. Other people have seen me and now got them, and they've liked it as well.
We
I
made him
would say
post his
nice.
picture of his setup because we wanted to emulate it so much.
Yeah. So I'd say if you have a standing desk, get this, and then you can either get one of those big fitness balls to sit on, because like walking an entire day is a commitment. But yeah, that or one of those other like stool chairs that you can just put on the treadmill when you do want to sit down, like I was doing earlier for podcast production quality. So I wasn't bouncing around. But yeah, that would be something that I'd like to share as my pick of the week, because it's surprisingly inexpensive way to really make a difference when you're working from home, which I know a lot more people are doing at least some of the time these days.
I feel like the next podcast, all the hosts are going to be in motion.
Adding to cart. Adding to cart right
As we
now.
speak, right?
There you go. That's awesome.
Fantastic. Yeah, no, it's really super small. It would fit actually on I have a little pad that protects the carpet from the chair. It makes it a little easier to roll it than rolling it on carpet. It would fit on that. And so,
You mean
yeah,
you don't
that's
want to be
perfect.
on your Peloton?
Well, this is an alternative to the Peloton. I mean, at least so you can work with your computer while you're doing the walking. I can't work on the Peloton. I can't do that on the Peloton. Like
Yeah.
those instructors are too tough on you. You can't. Yeah. Yeah. But super cool. Super cool. I don't have a pick of the week this week, but does anyone else?
Not
Well,
me this week, no.
Sort of. You guys already know, but this counteracts Eli. Okay, you guys know my
Oh,
co-host,
I know what these
and I
things are.
just got a chair because I had a crappy chair, Eli.
You
It
should
was
have done
horrible.
the unboxing. I heard so much about this chair already.
I know. I still have the box in the garage. I could take it apart and put it back in if I wanted to, but you can kind of see. Let's see. Where is it? Here it is. Hold on.
Is that Sura's chair? It looks like the same style you have.
I can tell you, hers was an inspiration.
You win, and it's a gamer chair. I've never had a gamer chair, so
It's ready self-dread.
it is ready. I did that on
Exactly.
purpose, honestly. So now I just have to get Elizabeth to pay for it. 'Cause I got the color.
He's getting
Just
me
put a
to
Renaissance
Seems
see
sticker
legit.
on it.
It's a home
Yeah.
office expense. That sounds like-
So I can't. I mean, I can walk. I get up all the time, but I'm counteracting you, Eli. I'm sorry. And you're that guy in the office who always kicking everybody's butt on, because we have them too. It's like, okay, guys, I can't even compete with that. I swear they put it on their dog and let them run for miles. It's gotta be.
Yeah.
So
No, it was fun. Someone suggested that we figure out a way to make the competitions based off of the number of steps you have at the like higher activity, like cardiac levels.
oh
Yeah.
yeah.
Okay.
Heart rate has to be at least 120, right?
Yeah. I
All
did
right.
have to put it on my ankle though, because if I'm just sitting with my hands, typing at the keyboard, it doesn't think I'm moving. So that was a was a
Okay.
concession I had to make to that. But I bike around, my hands don't move. I'm like pushing the running stroller. I'm doing this. So I was like, all of my favorite forms of exercise don't involve my arms moving. So it's a easy
Interesting.
transition.
Available on Amazon.com.
.com.
I feel like Eli's gonna have an affiliate link in our description or something.
Yeah, that'll. I have to make it in the show notes. Yeah, there's a few options that they have here. I can see on the Amazon site. But yeah, it's always fun to order things of this size from Amazon. I ordered some Peloton weights one time from Amazon. And I hear the boom in front of the door. The delivery drivers, I'm sure, like, yeah, you had to order weights. Great. It's just dead weight. Awesome. Love delivering that. This is approaching that size, of item for somebody to
Yeah.
have to bring out the
Yeah, it
cart for.
is. It does all come at one piece. No
Oh, yeah.
assembly required.
Thank goodness, because a treadmill I think might go sideways. Somebody trying to assemble it, at least me. Anyway, well, I want to thank you very, very much, Eli, for coming on the podcast. It's been an absolute pleasure to have you, and we're looking forward to future episodes. We're bringing you on, and yeah, thank you again.
You're
Yeah,
going
thanks
to
for having me.
SLAS, Eli?
Yeah. So I'll see you guys there.
Awesome.
For sure.
All right, maybe we can.
That's
Well,
great.
so we are conspiring to do a show while we're at SLAS. so maybe if we happen to be in the same place at the same time, we can.
There was discussion that we're going to be on the Midway. I haven't confirmed, but I can't deny, but I don't know.
Wish us luck either way.
Yeah.
Right.
Yeah.
Exactly.
Yeah. All right. If I see someone walking around with a big microphone, I'll come and say hi.
Look for one of these or four of these actually, yeah, because we're gonna be all on microphones, and Jeff's got a nice setup for being able to record 4 people at once. So we'll see, but looking forward to seeing you at SLAS, and as part of our, thank you again for coming on as part of our SLAS 2025 lead up series, and with that, the Helical Brew Crew is out.
Thank you for joining us on the Helical Brew. We're glad to have you with us. For more episodes, please visit our website at helicalbrew.com. That's helicalbrew.com.